Hi friends. In the previous video, I was already explained the basic operation of 8259 IC, also call it as a interrupt controller IC, right? So now in this video, let us see what is the block diagram as well as what is the pin diagram of 8259 IC. Okay. Let us see. See the topic, block diagram as well as pin diagram of 8259. Okay, let us see block diagram and pin diagram of 8259. Okay, this is called it as a block diagram and this is called it as a pin diagram. Okay, let us see here also how many pins are present. 28 pins are present. First we'll see briefly block diagram, then later we'll see functioning of each pin. Okay, right. So coming to block diagram, let us see what are the various blocks present. One is called it as a control logic. Okay, this is called it as a control logic, right? Then total 4 registers are present here. Interrupt request register, what is short name? IRR. Then priority resolver, then in service register, nothing but interrupt service register, short name is ISR. Then interrupt mask register, short name is IMR. Like that, 3 registers are present: IRR, IMR and ISR in this block diagram. Then there is a data bus buffer, then read write logic, then cascade buffer comparator. Like that we have blocks. Let us see first what is the role of how they are connecting. Okay, see here, interrupt request register IRR receiving request from 8 pins, IR0 to IR7, receiving request from 8 devices. Okay, so in order to make any request, which register is receiving request? IRR. Then after receiving the request, that information is processed to priority resolver. Okay, priority resolver is communicated to which one? Control logic. Then interrupt service register, after making priority resolver in association with the control logic, then that information is transmitted to interrupt service register. Okay, now interrupt service register as well as interrupt request register connected to internal bus. This is internal bus. So then there is a interrupt mask register. Interrupt mask register is also connected to IRR, IMR and ISR, and it is also connected to internal bus. Then control logic connected to priority resolver. Interrupt request register information is also given to control logic. Control logic having 2 pins, INTA and INTA bar. We'll see detailedly. Then data bus buffer also connected to internal bus and it's a bidirectional. Okay, and this data bus buffer is connected to lower byte of Prasad data bus D0 to D7. Then read write logic having read operations, write operation, and it is having only one address line, name it as A0, and there is a chip selecting signal CS bar. And there is a cascade buffer comparator that we have 3 cascade pins, CAS0, CAS1 and CAS2, and SP bar / EN bar is a one more pin. Okay, like that pins are present. Let us see first functioning of data bus buffer. See, the data bus buffer is mainly used to communicate data transfer between lower byte of the CPU as well as 8259. So in order to transmit data, 8-bit data between CPU, lower byte of CPU and 8259, the data bus buffer is mainly used. Sometimes the data bus buffer receiving data from the CPU or sending data to CPU with the help of 8 data lines present in the data bus buffer. Okay. Then other is read write logic. So in order to perform read operations or write operations, okay, so read write logic is essential. Okay, here read bar, write bar, A0 and C0 are present. Okay, so in the pin diagram I will give you functioning of each one separately, read bar, write bar, how they are functioning. Okay, simply read write logic, this logic will control read and write operations. Normally you see, so if you take only 18259 and one CPU, in that case what happens, CPU wants to read data from the 8259, then it will activate read bar. CPU wants write data to 8259, then it will activate write bar. Like that read bar, write bar signals are essential. Then in cascade buffer comparator, so we know 8259 operate in cascade mode. In that mode what happens, one is act like a master and other are act like a slaves. In that case what happens, here we are using these 3 cascade bits in order to communicate between master and slave. Okay, for master these 3 pins are act like a output, and for slave these 3 pins are act like a input. And generally master will provide initialization code to each slave initially with help of CAS0 to CAS2. 3-bit initialization code it will assign for each slave. Master will assign initialization code to each slave. So whenever CPU giving interrupt acknowledgement signal, then master again sending same code to the concerned slave. Then slave understood that it will execute the instructions with the help of CPU at that time. SP bar by N bar is whether we are selecting slave or master is resetted by SP bar / En bar pin. Okay, then other is control logic. This is important. So control logic controls all interrupt request operations. So whether we are, which interrupt request we need to provide highest priority. Okay, that is controlled by control logic. So with the help of control logic, what happens? This control logic is further controlled by processor. So with the help of control logic, 8259 sending request to processor via INT signal. If processor is ready, it will send INTA bar signal to control logic, and control logic decides priority levels for all interrupt requests. Okay, so all are controlled by control logic only. Now coming to registers. First is interrupt request register. Short name is IRR. Interrupt request register. See the name, interrupt request register. Let us see the interrupt request register is used to store the interrupt levels of all interrupts which are requesting service. So which interrupts are requesting interrupt service? So all those interrupt levels are stored in the interrupt request register. See what is the role of interrupt request register? Interrupt request register will store the interrupt levels of all interrupts which are requesting the interrupt service. Okay, that information is present in the interrupt request register. Then interrupt service register. What is the role of interrupt service register? Interrupt service register will store all the interrupts which are being currently serviced. So interrupt service register stores the interrupt levels of all interrupts which are being currently serviced. Okay, that information is present in the interrupt service register. Okay, then other is interrupt mask register. This is important. So interrupt mask register stores the masking bits of interrupts. Interrupt mask register stores the masking bits of interrupts. Masking means making all zeros. Okay, they are not processed. Those interrupts are called as a masking bits of interrupts. So interrupt mask register stores the masking bits of interrupt. Okay, so whenever if any interrupt is masked with the help of program, okay, that interrupt request is not recognized by interrupt request register. Here, whenever if any interrupt is masked with the help of software, then that particular interrupt request is not recognized by interrupt request register. Okay, like that we have interrupt mask register. Then let us say other one is priority resolver. Priority resolver will makes the priority levels for the interrupt request. So this priority resolver will provide the priority levels for the interrupt request. Okay, so which one is having highest priority, which one is having least priority, that is decided by priority resolver. Okay, in association with the control logic. Okay, for example, among 8 requests, for example, one request is having highest priority. That information is conveyed to interrupt service register with the help of priority resolver. So priority resolver will take the request from all the interrupt request signals from the IRR, and later it will provide the interrupt levels to each interrupt request signal in association with control logic. Okay, and which interrupt is having highest priority, that information is conveyed to interrupt service register, where the corresponding interrupt is being serviced. Okay, so if any interrupt interrupt mask register, nothing but it will store the masking bits of interrupts. Okay, and one more is interrupt service register. Okay, is mainly programmed, or it is mainly programmed with the help of operational control word. There is one operational control word is present. Okay, in 8259, accordingly interrupt service register will operate. So in the coming video I will give you briefly what are the various operational control words of 8259. Okay, so based on that we can understand okay how 8259 may performing the interrupt request operations effectively. Okay, so finally what is interrupt request register? Interrupt request register receiving the request from all the interrupts devices. So simply interrupt request register will store the interrupt levels of all interrupts which are being requesting the service. So interrupt service register is used to store the interrupt levels of interrupts which are currently being serviced. Interrupt mask register stores the masking bits of the interrupt simply. Okay, and if any interrupt is masking in the software or in the program, those interrupt requests are not recognized by interrupt request register. And ISR is controlled, interrupt service register is processed the interrupts as based on the program specified by the operational control word register. Okay. Okay. Now coming to pin diagram. Let us see pin diagram of 8259. So pin diagram of 8259 contains total 28 pins. Pins in one side and 14 pins in other side. Let us see first CS bar. So you know what is the role of CS bar? Whenever CS bar is activating, then only 8259 is ready to communicate with 8086. Okay, if whenever CS bar is activating, then only it is ready to communicate with 8086 or other peripheral devices easily. So we should activate CS bar. Then what is other one? Write bar signal. So whenever write bar is activating, what happens? Processor, okay, writes data to status information to 8259. Whenever write bar is activating, the CPU sending status information to 8259. Now read bar. Whenever read bar is activating, then 8259 sending control information to 8086. Whenever read bar is activating, 8259 sending control information to 8086. Whenever write bar is activating, 8259 receiving status information from CPU. Okay, this is from CPU. This is sending to control information to 8086. Then D0 to D7 are the bidirectional data lines, and these lines are used to transmit data, okay, between 8259 data bus buffer and 8086 data bus. Then cascade bits here, CAS0, CAS1 and CAS2. These three are mainly used in the cascade mode of operation. In that mode, one 8259 is act as a master and other 8259s are act like a slaves. And master will provide initialization code to each slave initially. Okay, so whenever a processor is giving acknowledgement, interrupt acknowledgement signal to the master, then at that time master again sending the corresponding 3-bit code to the slave, which is currently being processed by 8086. Okay, in that case, CAS0, CAS1 and CAS2 are essential. So with the help of these 3 bits, so master will giving initialization code to each slave. 3-bit initialization code to each slave. Whenever processor is giving interrupt acknowledgement to master, then master again sending 3-bit initialization code to the corresponding slave, which is being processed by the, which is now ready to processed by 8086 with the help of 3-bit code by using CAS0 1 and 2 bits. Okay, then ground pin provides the protection against the overcurrents or short circuits. So ground is essential. Then other is SP bar / EN bar. This is important. SP bar is slave program bar / enable bar. So whenever pin number 16, nothing but SP bar / EN bar is connected to ground, then the corresponding 8259 is act as a slave. Means we are activating slave. That's why you know that 8259 is act as a slave. So in order to make it 8259 as a master, then SP bar / EN bar is connected to VCC. Whenever SP bar / EN bar is connected to VCC, nothing but 1, then the corresponding 8259 is act as a master. Whenever SP bar / EN bar is connected to ground, then corresponding 8259 is act as a slave. Okay, then INT. INT is interrupt signal, okay, or interrupt request signal. So with the help of INT signal, so the master is sending the master is sending request to processor with the help of INT signal. So this INT pin is connected to INTR of CPU. Okay, with the help of that, master is requesting the processor for executing the instructions. Means for sending the interrupt acknowledgement signal and execute the instructions. For that, it will with the help of this INT, it will send the interrupt request to master. Then INTA bar. INTA bar is interrupt acknowledgement signal. So processor, if it is ready, processor sending interrupt acknowledgement signal with the help of INTA bar. So this INTA bar pin of 8259 is connected to processor INTA bar. Okay, with the help of this pin receiving the acknowledgement from the processor. Okay, this pin sending the interrupt request to processor. See the difference. Then IR0 to IR7. They are called it as interrupt request 0 to interrupt request 7. All are 8 interrupt request pins. With the help of IR0 to IR7, master will receiving request from 8 slaves. Master will receiving request from 8 slaves. If it is slave sending INT signal to IR0 of master. For example, if you take one slave is also having INT signal, right? The slave INT signal is connected to master IR0 signal. Okay, like that, all slaves are connected to master via IR0 to IR7. Okay, in case of cascade connection. Then A0. So 8259 is having only one address line, call it as A0. And VCC is a power supply pin and it requires 5 volts power supply for operating 8259. Okay, like that, the pins total 28 are present, and for cascade operation, CAS0, CAS1 and CAS2 are important, and with the help of these 3 pins are act as output pins for master and input pins for slave, and master sending initialization code to each slave, okay, before cascade operation. So whenever processor giving interrupt acknowledgement signal, master again sending initialization 3-bit initialization code to the corresponding slave. That slave will receive grant. Accordingly, the instructions that are present in that particular slave is executed by the 8086. So with the help of these 3 pins only we can decide. Another is for selecting slave, SP bar by N bar is connected to ground, and for selecting master it is connected to VCC. INT is the input request signal to the with the help of this pin 8259 sending interrupt request signal to processor. Okay, with the help of this pin 8259 receiving interrupt acknowledgement signal from the processor. A0 is the address line. So now CS bar is just for making chip selection. Whenever chip selection is occurred, then only read and write are possible. Similarly, interrupt request receiving, everything is possible. So write bar, whenever write bar is activating, what happens? CPU sending control information to 8259. Whenever read bar is activating, 8259 sending status information to 8086. D0 to D7 are data lines. Okay, similarly, INT and INT are like that. We can analyze pin diagram as well as block diagram of 8259 in this particular fashion. Okay, I hope you understand the basic block diagram as well as basic pin diagram of 8259. So in the coming video, let us see the operational control words of 8259. What are the various operational control words of 8259? We'll see detailedly. Okay. So thank you for watching this video. I hope you understand the block diagram as well as pin diagram of 8259 effectively.